Okay, great. It'll just be this small group, which is fun. Um, Feel free to turn on your videos and say hi if you want to at any point. This is kind of maybe different than some of the other sessions in that I'm going to be giving a lot of information up front, but I am hoping that we can have a good discussion at the end, kind of after I talk about what data pipelines are and what targets is. And yeah, I'm hoping we can have some good interaction there at the end, and maybe by that time more friends will have joined us. Yeah, so my name is Lindsay Platt. I am an environmental data scientist at CWASI, which is the Consortium of Universities for the Advancement of Hydrologic Science Incorporated, if you're not familiar. I am a really big fan of targets. I used it in my previous job at the USGS, and I think it's a really great tool. I basically use it for all of my research and kind of any data work I have. I even use it for budget tracking and visualizations. So I wanted to kind of present it today to this community and just see what people thought about it. And I'm joined today by my colleague Abner Bogan.
Howdy. Thanks for the intro, Lindsay. I'm super happy to be here. Again, my name is Abner Bogan. I am also an environmental data scientist at Quasi. And for me, I'm a very new adopter of targets. I primarily use Python, but I'm increasingly starting to use R to support data work. And I'd say I'm very actively learning the different ways that I help streamline my data work. So yeah, happy to be here.
Yeah, great. So we thought we would start and just learn a little bit about the group that's joining us. So we're small, but yeah, still interested to hear kind of what about this session caught your eye compared to the other ones. So in the notes doc, actually, if you scroll below the attendance section, you'll see a space to put these thoughts. So if you're willing, if you could just add your thoughts to this initial question. Yeah, I'm just kind of curious because one, we have quite a few Python folks here, which is cool. And I'm always interested to know, yeah, people's kind of reaction to data pipelines and kind of workflow tooling. So there's this question, and while you're filling that one out, there is actually another one below it, if you wanted to do that as well. So the second one is, what's your familiarity with data pipelines, and maybe even the specific package targets? I think it's, you know, maybe unfamiliar, but the data pipelining kind of concepts might be familiar to you. So I'm just kind of curious to learn more about your experience level here. And I'm just going to be kind of reading. I have like 5 screens going on, I feel like. So apologies if I'm not looking at you while I read some other things. But cool. Some people have tried targets a few times. Yeah. Yeah, and now there's like more requirements for having runnable or like reproducible code for journal submissions, which is great, but if they're not providing the space to actually learn how to do that, can be challenging for sure. Yeah, and I think someone wrote lowering barriers to making it happen. I think that's probably one of my favorite things about targets is that it's a pipelining tool that's in a language that people are already familiar with. So they're not having to make quite as big of a leap to learn the tool. So yeah, new to targets, more familiar with pipelines. Some folks are unfamiliar. Oh yeah, R Markdown for reproducible figures. Yeah, R Markdown's kind of like a nice, really like simple, kind of contained example of not exactly a a pipeline the way I think of it, but it's definitely a reproducible example, which is cool. Yeah.
One thing that I'll
Okay.
add is that as a new user of the targets package is I think that it's a good starting point. Like if you're not as familiar with pipelines, at least for me, just like being able to visualize your pipeline and inspect like the different attributes. I found it really helpful. So I just wanted to add that real quick.
No, yeah, that's great. Thanks. Um, yeah, okay. So thanks for sharing a little bit about yourselves. So this is going to be kind of a mix of some slides, some opportunities for you to actually code alongside of us, and then also some time for a discussion. So we're just going to talk at the beginning, and kind of introduce the concept of a pipeline and compare that to maybe just, data workflows. And then Abner's going to give an overview of where you can find the materials if you wanted to choose to do any of the kind of active participation. Though you can certainly passively participate, that's completely fine. And then I will go over some slides introducing the package itself and how it's structured and some of the key functions. And there will be opportunities in here to try out running different functions with the code that we've provided. And then, yeah, just kind of close out generally on this concept of dependency management, which is what data pipelines are really about, which is like kind of tying together different steps in your workflow, so that they are, yeah, linked and will update as things change. And then, yeah, just kind of talk about your reactions to seeing this tool. I have a couple of prompts in there to get the conversation going. So looking forward to that part of this session together. Okay, and with that, I will just go ahead and get started here. So I am, this is kind of my definition of like the distinction between a workflow and a pipeline. So I like to kind of compare and contrast or introduce pipelines by comparing and contrasting these two terms. So I think of a workflow as, kind of your conceptualization of how data is managed in your project. So how do you get from the raw data to the final kind of output products? And so, a lot of times people are kind of capturing these, maybe not explicitly, but if they were to, they would make some kind of flowchart visualization. And so that's just a workflow. It's just describing the process. But to me, a data pipeline is the actual like programmatic implementation of your workflow. So it's actually the coded steps that transform your data or run a model or something. And the idea behind a data pipeline is that there's minimal human interaction needed in between the steps, other than, originally coding it. But the actual like process of moving data from one piece to the other is not like a manual thing. And so I am going to introduce kind of an example that we can use to go through this data workflow to data pipeline concept. And I come from the water quality and water world. So my example is water-based. And so let's imagine that there's 3 collaborators working together on a research project. Maybe they're modeling river temperature, and they need to produce, they need to run a model, they need to produce figures and tabular results. So they might construct a workflow that looks something like this, where again, I come from a USGS background too, so I'm referencing NWIS, which is the National Water Information System from the USGS. So these are our raw data inputs. They're getting stream flow and temperature. And then maybe they need to combine these and kind of prepare them for their modeling. They may also get some geospatial data from the National Hydrography data set. So now they have river segments, and they include all of these data in their model, and they end up with model temperature in each of the river segments. And then they move on to plotting the results and observations. And so this kind of workflow is capturing the data products associated with the project. So raw data, some cleaned up data, some model data, and then this kind of like data artifact, which is a plot. But so for each of these data artifacts, there's a process associated with getting this data to that point, which are represented by these circles. So maybe you're downloading it, you're doing some kind of join with the data, you're running the models, and you're building the plot. So there's the kind of data itself and then the process to get it. And so in a project, oftentimes with multiple collaborators, those collaborators are responsible for different parts of the project. And so with our 3 collaborators, they may each be taking on a different process as part of this. So that's represented by these different colors. And a kind of another step to all of this is when you have different people in charge of these different processes, somehow the data has to flow in between the people too. And so, maybe you have a shared drive, like in Google or some other space, but sometimes people are even emailing. So now the arrows are kind of up to different people and they're using different mechanisms to actually share the data. So this to me kind of feels like, for a simple project like this, a bit of a complete workflow or conceptualization of getting from the raw data to the output. And I can see, a lot of people maybe going kind of the one step further than this, which is actually having these different steps coded. And so, when you code each of these individual steps, you might have a script or something that downloads the data or combines them or builds the plot. And this is a really great, great step forward in terms of being able to more confidently rerun your analysis. But I think one challenge to this is kind of the people management side, which is, making sure that you're running, if you're the purple person, you should be running you're the model with the most up-to-date data. And this becomes a little trickier when you don't have things formally connected and they're just kind of people responsible for the different elements. I would never like to find out that I've been building a model and maybe calibrating it based on something someone emailed me that was called temp_final, only to find out that they had later emailed me something called temp_final 2. So to me, this is a lot to keep track of, even in this simple example. And most of the time, we're not in this kind of 3-person, very straightforward workflow or project. A lot of times we have more people. So as you're adding more people, now you're increasing the complexity of who's in charge of what step because they're an expert in this or that. And then, there are usually more steps. And as you start to add more steps, things get a little bit more complicated for who's responsible for them and how they kind of integrate with the rest of the picture. And then on top of all of this, we know that you're not going to do this just once. Most of our science, we need to go back and iterate or refine. And so if you had to go back to the beginning, say, and re-pull some of the original data, how are you making sure that the right people are getting notified, that they need to use a different version of the data, and kind of like with my temp_final 2 example, how are you tracking and making sure that they're using that correct version? So to me, even in this simple example, just speaking about this, like I'm getting stressed out. Like this is a lot, I think, to keep track of. And so, just here, not even thinking about maybe some of these other elements that are making it kind of increasing this like mental burden on tracking your analyses. So, our science is having to use larger and larger data or more complex data. We're building these bigger teams. And also, just like someone mentioned in the notes document, there are new requirements for publishing our data and models, which is great, but it's just adding to the complexity of kind of the tracking of where things are at in a project. And so we can actually look into pipelining tools to help us achieve more complete reproducibility and, aid in the collaborations and help us increase efficiency as we're scaling our analyses and kind of facing some of these more stringent requirements for publications. And so if we go back to this workflow example and switch kind of into pipeline mode, to me, when I think about pipelines, I think about now the computer becoming another collaborator, essentially. And this collaborator is now responsible for all of these kind of processes between the data artifacts. So we're shifting a lot of that kind of mental burden associated with tracking data products at these various steps and stages onto this pipeline that we're building and to the computer. And so what this allows us to do as scientists is then spend more time kind of at the end, thinking about the results and the observations and being more willing to iterate on what the outputs are. And so, maybe that allows us to make and feel more free to make changes to the model to improve something or, see what a change might do to the results, because we know that we can always revert that change and rerun things. And those changes would propagate appropriately through all the different connections that we have. When I'm thinking about pipelines and, while there is like a startup cost to constructing them, I think the benefits are that you get kind of more free time later to be innovative about the actual science that you're doing and comply with some of the reproducibility requirements. Yeah, so that's kind of like my view of workflow versus pipeline and what it means to kind of jump into motivation for why you might jump into pipelining tools. One big thing that is important when you're constructing pipelines that I wanted to spend a little bit of time talking about is modular code. And so writing custom functions that are able to kind of take, one kind of like section of your analysis and like break it into a smaller piece is a really great way to organize just your scripts. Even if you don't go the full pipeline route, it's a way to kind of break down, maybe you have like a 400-line script or something. You can start to kind of break it down into these more manageable chunks that are kind of better describing different steps in the workflow. So it just makes it easier to read. It also makes it easier to reuse your code later for something else if you needed it to. And yeah, it just kind of helps you better conceptualize how your data analysis is working too. So this is kind of a big part of writing data pipelines, is that you're moving from big scripts that have every line of code you've done for your analysis into this kind of modular space where you're writing functions, and then ultimately into a pipeline. And I have some further reading here. The slides are linked and available in our resources for this session. So I just wanted to give an example of this. This is actually the example that's used in the targets documentation. And so it's just this, kind of tiny example of running a model on some basic data. So there are kind of 3 steps here. The first is that they're reading in some data, cleaning it up by filtering it, and then they're fitting a linear model to the data, and then ultimately they're plotting this model. And so this is just an example of what the script would look like in R. It's simple, so it is easy to follow, but you can imagine an example where they get quite large. And so you could modularize this script by writing a function that contains each of these individual steps. And then that function is named really clearly for, what is happening in this step. So the example here, there's now a function called read and clean. There's a function called fit model and a function called create plot. These are still kind of basic terms. I'd probably get a little bit more descriptive in them if I were actually writing this, but still good as an example. And then you could see kind of the modularized version of this by taking it one step further and showing how you would call each of those functions. And so you would just have this one script that calls each of the functions, that does the reading and cleaning, does the fitting of the model, and then creates the plot. And so this is just, you know, kind of hiding some of the interior code so that you can just kind of straightforward see like what are the steps in this workflow. But you can always dig into each of the functions if you wanted to know what the details of that function are. But it kind of, you know, is showing this more like overall view of how the, yeah, how the data is getting from raw into plotting. And then by having functions like this and having things modular, it makes it much easier to, oh, sorry, here is the example of what the script was versus the kind of function modularized version of this. But by having these in functions instead, it makes it easier to extend the code to do something else. So you could very easily in a small amount of code reuse the functions, but pass in different data. And so that's just like some of the benefits to moving into this modular space. And I would say even this step of going from scripts to writing functions is a really great kind of intermediate space to try to get to if you're not going to go all the way to data pipelining. Like even just getting to here is a really great improvement for reproducibility. Okay, so oh, I see a key, a question. Is the .r my function script the same as providing a source script? I'm trying to understand that question exactly. Oh, I see what you're saying. Okay. So this source call is what you can run. It basically just like executes the code that's in a script. So it's similar to just pressing the button run or highlighting all the code and clicking Control Enter. It's just an automate, like a kind of function you can call to do that on a file. Yeah, good question. Yeah, and so this is what is needed in order to load the functions and then call them. Yeah, okay. So that's just kind of my introduction to workflows and pipelines. And yeah, kind of this like why modularity is important. And we're gonna kind of pause on the like slide material for a minute, and Abner's going to go over if you wanted to actively participate in kind of the next phase where we're working with a pipeline. Abner's just going to go ahead and describe how to access that data, or not data, the workshop materials. But again, you do not need to do this step unless you want to actively yeah, run the code.
Hey, awesome. So I am looking at the agenda right now, the Google Doc embedded in our session, which contains the code setup instructions. So under resources for the session, you can go to the second link. It's just a README that they can follow along directly to download the zip file containing the code for the workshop and then load the relevant libraries. So I will download the zip file. It won't take too long. Okay. So it is in my downloads folder. Let's see, right there. And I'll just extract it. I'll just keep it in downloads for now. while that's going, we can open our studio. Lindsay actually just mentioned to me that you could open the project file by clicking on the project file in the root folder of the directory, or you can open our studio. Hopefully everyone can see us okay. Let me know if there's any issues with seeing my screen. You can go to File, Open Project, and let's see, Downloads. And then we're looking for that R project file, which changes the working directory and uploads whatever settings were specified. Okay, so now we can see.
Hey, Abner, could you
Yeah.
pause real quick just in case people are following and want to catch up?
Oh yeah, for sure.
Yeah.
Sorry.
Yeah, you're good. Yeah, so you downloaded the zip, you unzipped it, and then you opened that .rproj file. And I see some people are clicking on it. I guess I would be curious to know if anyone is actually going to actively follow along. I guess we'll maybe I'll use like maybe people can react in a moment so that we know.
Yeah, if you've opened your project in our studio, feel free to give a thumbs up, or
Yeah, it'd be useful.
and if not, if anything's not working, please don't hesitate to let us know. Oh, thank you, Cassandra.
Yeah, and all the materials will be there afterwards too. So if you don't want to do this while you're in the session, you can always access them later too. Oh yeah, thanks for oh yeah, you do have to have R installed already. So if you don't, that will not work. Sorry, Madison. But yeah, all the materials will be there for you later, including that setup instructions document. So you should be able to kind of recreate things afterwards. All right, Abner, I think you can go ahead and do the next step.
Okay, cool. So we're on now step 5. So we just did 1 through 4, download a zip file, extracted the contents, opened our studio, and then opened the project in our studio, which is right on the top right. So now we can install the targets package, which is used for this dependency management. And you can just copy and paste in the command in step 5 to the console right in our studio. And you should see that it installed successfully. The next step that, or I guess the last step really, before you have everything configured to run the contents of the workshop, is to download additional packages for visualization and data fetching that are defined in this vector here. So you can just do the same thing, copy these packages, which are also defined in this underscore targets.r file. You can just copy that and enter in the console, press enter, and then it will download all those packages and you are good to go.
Yeah, and if you already have them, it will update the version that you have by installing the new one. Yeah, okay, it looks like at least one person is doing it, which is cool. I guess the last step, Abner, could you run the library command for
Yeah,
targets?
thank you.
Yeah.
Yes. So yeah, this is just to confirm that targets is loaded, and now if you want to run functions within targets, you can do that. So yes. So yeah, you should run library targets to if you're continuing to follow along, so that you can execute the pipeline.
Yeah, great.
Were there any just want to double check if anyone had any questions with that process? Because this you can access this material after the workshop as well.
I don't see anyone having big red flags who is potentially following along, so that's good. Yeah, feel free to just drop in questions as you go. We won't have time to troubleshoot like package install issues here, but happy to follow up with you later if you try it and have some issues. Okay, great. I will steal the screen sharing back. If you could end it, Abner. Yeah, okay. Maybe I could have stolen it, I don't know. Okay. Are you seeing the slides again? Okay, thanks, Abner. Okay, so this was that kind of pause for activity. I'm trying to also get my chat back up. Come on, Zoom. There we go. Okay. Great. Okay. So again, you can just passively participate in all the future stuff if you did not follow along here. All right, but I want to introduce the package itself. So the kind of tool that we're using to implement a pipeline today is an R package called Targets. It was developed by Will Landau. It's supported by the R OpenSci community. And I think, while there are other options for tooling, kind of like I said at the beginning, I like this package because for people that are already developing in R, maybe they're doing all of kind of their science in R, it's easy to, I wouldn't say easy, it is complicated, that's kind of downstating it, but it's not as big of a jump to learn yet another language or kind of framework for building a pipeline because it's written in R. So yeah, it's just like one more kind of barrier or one less barrier to adopting a practice like this. This package is also really well supported. I have asked a number of questions to the developer with pretty quick response time. So that's been a really great experience with using it, and the community around it's kind of developing and growing. So, there are some other like companion packages to this one that's built, and it's just, yeah, becoming a little bit more used, which is great. Okay, so there are some kind of specifics to setting up a targets pipeline. So once again, I'm going back to that example before, which is this kind of read and clean data, fit a model, create a plot. And then I'm going to compare it to what it would look like in a targets data pipeline. So this is what we had before. Maybe it's this script is in a file called run_model_workflow. And then if you were to actually want to run this code, you could click the run button in RStudio. You can also do the keyboard shortcut, which is what I do, to select everything with Control A, or if you're a Mac person, Command A, and then Control Enter to run it all. So that's how you would execute the code here. We will compare and contrast this to what the same workflow, but in a targets pipeline looks like. So there's a lot here, but I'm going to walk through some of the key differences. So first off, the kind of what I like to call the recipe file, or essentially like the instructions, must be in a file called _targets.r. I know that's kind of awkward because we usually don't start file names with an underscore, but that is the requirement here, the package will specifically be looking for a file called _targets.r. And if you don't have it, it won't run a pipeline. So in this file is where you specify the steps in your workflow. And so here, the very first thing we're doing is specifying the packages that are needed. And so the very first thing is just loading the targets library. But then any package that's needed by the steps in your workflow go inside of this tar option set function. Because ultimately what happens when you build a pipeline is it runs it in a new environment. And so they're just a little bit of a different kind of configuration to get it set up and have the packages and things it needs. So that's where packages are specified. And then the steps in the workflow must ultimately all go in one big list object. So you'll see here that all these steps are wrapped by this command called list. And each step has to be defined by a function called tar_target. That's what sets up this kind of step. And I'll talk a little bit more about some of like what's going on inside of this function, but essentially the first argument to the function is a name that you pick for the target. Could be anything. So I've written it to kind of match-ish, although I'm noticing it's not matching exactly. I should have done that differently. The name of the object on the left, but that's just a name that you get to control and pick. And then the second argument to all of these functions is the command or the code that must run when the target is, or the step is built. And so that's kind of like moving from the left to the right. All of those steps now go inside these tar target functions. There is a fourth one here. You'll notice we go from 3 steps on the left to 4 on the right, and that's just because of how targets handles files. So I'll go into some of the different target types that you can have. It's just that first one in the list is saying, hey, this is a file. You should track the contents of that file and not just the name of the file. And then the last major difference here is how you run the code. So if you just had a script, you would click run on the script that you had, or select all of it with Control-Enter or Control-A and run it with Control-Enter. If you have a targets pipeline, once you have it set up, you would just run the function tar_make, and it would build the pipeline for you. Okay, so again, there's a lot of words on this slide. I'm hoping this can serve as a really good resource for you later, but I want to go through some of these things. So first, what exactly is a target? They're using target to really mean the step in your workflow. And then each of those targets has to be defined using that tar_target function. Then you choose the name as the first argument, and then the second argument is what gets run when it's built. And another key thing about each target is that it should only be returning a single thing. It can be an R object or it can be a file, but in the end, it can only return one thing from the function. So the first, which is maybe the more common target type, is an object target. It's really anything that can be saved as an object in your R environment can be saved here. So you could save an actual model, you could save data frames, you can even save plots, lists, anything that can be an R object can be the output of a target. File targets are a little bit different. That's that kind of fourth one I was mentioning in our example before. If you have a target that saves a file, or you're kind of setting up to be reading a file in, you would use this additional argument in your tar_target function, and you would specify format equals file. And this is useful because if you didn't do this, it would see the kind of string, the file path as like your character string, and it would treat that as uh, the element that it was tracking updates to. And so if the name of your file didn't change, it wouldn't rebuild anything that was dependent on that. So by adding format equals file, you're ensuring that the contents of that file are tracked. And if the contents of the file change, it would trigger things that depend on it to rebuild. The last one here, I don't want to get too much into it right now. You'll see an example of it in the code that we have to share for today. But there is also the option to have these dynamic targets, which is essentially, you can kind of think of it like a for loop or a mapping. If you were to do this in a script, it's a way to apply the same function to multiple inputs. And it's I think it's a really powerful way to use the pipelining tool. So you essentially define a target that has the values that you would like to map over. And then you would set up a future target to have this additional argument called pattern, and you would map over that earlier target. So you can very quickly kind of expand the utility of a function to be applied to, in this case, many sites. I've seen it used as like mapping over states, mapping over, maybe we'll do, I guess we're doing sites in this example, but you could also map over different parameters in your data set too. So a powerful way to kind of quickly scale your pipeline. Okay, so other things kind of within the targets repo or project that you're working in. So we talked about this before. You need that underscore targets.r file. That is the kind of file that orchestrates everything else. I call it the recipe. Very bare minimum structure for that is that you load the targets package, and then you have one simple target in a list, and that's it. That will run, that will execute. If you wanted to build your pipeline, you would call that tar_make function. Again, it runs your pipeline in a new environment. So if you had any packages or objects loaded in your current environment, it won't care about that. You need to kind of pass all of that key information in using the kind of recipe file. And then the other kind of key part when building pipelines is that after you first build a pipeline, you will see a new folder be created that's called _targets. And inside of that folder is essentially all of the metadata that the pipeline is keeping about what's been built, how long it took, what the size of it was, how it's connected upstream or downstream to other targets in your pipeline. And if you're building a pipeline as part of like a Git or GitHub project and version control, I always git ignore this _targets folder just because there could potentially be a lot of data in here to track, and that's not something that you'd want to check into Git and GitHub. So that's just kind of my practice for that. The last part I wanted to share here before I just shared my screen and gave you a tour of our example pipeline is, there are some conventions that you could adopt to improve the readability and reproducibility of using this kind of targets pipeline approach. So everything I showed before is kind of like, this is how you have to use targets because that's how it's designed. This slide has information that's like conventions that you could follow to help make it more readable, though it's not a requirement to actually run the pipeline using the package. And a lot of these I used with the USGS water data science team before. These were like standards that we had come up with when we were using a previous pipelining tool, and then we kind of extended into targets. And so the first is just like basic file structure and target naming, when you start to build really complex pipelines, it's incredibly helpful to have chosen as a naming convention for your targets and kind of organization of your files and folders. So we followed a convention, and I still do to this day, where I'm numbering phases in my pipeline. And I have like literally a numeric value and then kind of a short descriptive verb about what's going on in that phase. And you can actually make different, you'll see it in our example, you can make different kind of recipe files and then combine them in that main underscore targets.r file. So if you have, hundreds of targets or something, you can kind of, modularize them a little bit better. And then I always prefix my target names based on the phase that they're in so that I can better keep track if a target failed or I need to load something specific. I know what phase of the pipeline it came from. So I use P1 to say it's in my 1 underscore download phase or something. And yeah, there's kind of shortcuts to being able to build chunks of targets if you wanted to. So if you followed a naming convention, it would be easier to take advantage of those kind of helpers to run just specific targets. And then the last like big convention I'll mention here that you'll see in the example is I distinguish the file and object targets based on the name that I give them. So if a target produces just like a data frame, I would call it P1 underscore data. But if that target actually saved a CSV file, I would make sure that the target name has the file extension at the end. And it just is for readability purposes. It becomes really easy to quickly see what's a file, what's just like an object. And also, I have found that by writing my target names like this, it's kind of a reminder to myself as I'm constructing it that I meant it to be a file target, and I may be missing, that key element that's like format equals file or something like that. And it's kind of like another trigger to remind me that something might be amiss if I intended it to be a file target. So anyway, these again are just kind of some conventions that I like to follow to keep things more organized, but they're certainly not requirement to actually just running a pipeline. Okay, so this is a reminder to myself that I will now stop the slides and share my screen. And yeah, I don't see any questions yet, but thanks, Abner, for keeping up with that. Okay, I think I can just go ahead and open this, and you should be seeing my RStudio now. Thanks, Abner. Okay, so if you open, if you were following along and you opened this project, you would probably end up in a view like this, where you see the console, and then you see we have this ESIP Jan 25 targets workshop folder that we're inside of. In the README, it's just a quick description of what this was built for and by whom, and just acknowledging that this this code and this pipeline example was also built in collaboration with Elise Hinman from the USGS. So thanks to Elise. So first thing I would say is to open the underscore targets.r file. Here is what this looks like for this kind of working water quality example I'm going to show. And I would say don't get too hung up on the exact example. It's a simplified water quality example, but it is a working pipeline that downloads data, cleans it, and produces some pretty cool visualization outputs. So here we have that library call. We're using the tar option set function that I shared before to define all of the packages that are required by the various steps in our workflow. Another convention I didn't talk about, but you can do in pipelines is I set these configuration elements that are just simple singular values that are going to be input to the pipeline. And I specifically put these here because I've made this pipeline parameterizable, so you can change these and rerun and get different results. And so these are just, some of the examples of kind of pulling out some configuration information to this top level recipe. This pipeline is one where I did do the approach of having different phases within the pipeline. So I define all of my targets in 3 separate R scripts. So I have 0, 1 fetch.r, and you can see here I have the list, and then it has the tar underscore target calls within it. Same with the 02 prep, I have the list, and I have the tar target calls within that. And it's the same in the third one, 03 summarize. So all of those are setting up the actual tar target values, and I'll pause on those in a moment. But I'm going to go back to our main recipe file, and you'll see that all 3 of those files that called the tar underscore targets functions and set each of our kind of steps up are called here using the source function. So that's what just runs the code. But ultimately, targets needs a single list of all of the targets. And so we combine those lists here as kind of the final step in our overall recipe file that's orchestrating everything. So that's how we're able to do these kind of phased.r scripts. It's by combining all of the lists into one in this underscore targets.r file. Okay, I'm just going to briefly kind of walk through what we do have going on here. So this, all the functions for this first phase are stored in this file, and so I'm loading them here at the top again with that source call. The very first thing that happens is it downloads data from the water quality portal. So we have this tar underscore target function that's setting up this first step. I named this first step P1 underscore data set. And then the very next thing that happens is it calls a function, and I'm passing in those configuration elements that I had specified on the first in this underscore target.r file. And then it's going to save that data set as a file target. So this one's a little bit more complicated because it's saving a file, so you have to have this additional format equals file. And I've named it with this underscore.csv convention. So you can see these things are tied together. It's just one's a CSV and one's an object. And I don't want to dwell too much on all of the specifications of how I've written this, because you can always go back to this as a resource. I want to be able to provide kind of an overview level here. And this example is slightly more complicated than the one that's just available in the targets documentation, because, you know, using earth science data gets immediately more complicated than their very simple example. So I wanted to provide this kind of working pipeline as kind of one more step beyond that really simple one. Okay, in our 02 prep, this is preparing the data for plotting, because that's all this pipeline's doing, is downloading data and then plotting it. We're cleaning it up using this function called refine WQP dataset that will filter to a specific characteristic that was specified in our configuration section at the beginning, and save it to this P2 refine dataset target. We have another target that's just getting the unique sites from this dataset and returning them as just a vector of sites. We're summarizing this data by site using this function. And then we're also getting some metadata from it. So again, the majority, the workhorse part of this are probably really what's inside of each of these functions. But by wrapping them, wrapping all of that code in these kind of descriptively named functions, it's a little bit easier to just read through and see what are the steps that are happening to this data. And then the last step I will share is our summarize phase. And the first summarize phase is to plot the time series, and it saves PNG files. And this is an example of one of those dynamic targets where it's mapping over each of the sites that we have in our data set and saving an output PNG for each of those steps. And then the last step in here actually creates an HTML file. So I think shout out to Allison who said that HTML was her language of choice. So it's saving an HTML file with a leaflet map where all these sites are and their some information using their kind of summarized data set. So that's what this whole pipeline is. And I just wanted to spend a few minutes like poking around it just so you could see what the code actually looks like. But I do want to spend kind of the rest of the time talking about how to build and actually run code when you already have a pipeline set up like this. We're going to pause here. Please ask any questions that you have in the chat. And I will just say, if you were trying to follow along with the code, go ahead and try running that tar_make function in your RStudio right now and just observe what's happening. And I'm just gonna pause and be quiet for 1 minute. And yeah, chat anything that has come up so far.
If anyone's able to run it successfully, don't hesitate to let us know.
Yeah, share.
No worries if not, though.
I won't pause for too long either. Oh, Madison, you got R installed in that time too? Wow.
Yeah.
Incredible. Okay, cool. All right, Sandra tried it. Wow, great. Okay, so what happens when you run it is you will immediately get way too many console messages, but they are important. So I am going to go ahead and just share here what it looks like to run it. So first off, you have to have the targets package loaded in order to use this function. So that's the first thing I'm going to do is load the targets package. Oh, that took a minute. Was not expecting that. Okay. And then you can just run this tar_make. And it then goes out and based on the fact that you have this _targets.r recipe file, it knows what all the steps are in the pipeline and it starts executing them. And so this is the first time through. And so it's running all of them because it had nothing before. So the first thing is this P1 data set. I told you it was downloading data from the water quality portal. So I'm just going to scroll back up. And these are the messages that come back from downloading data using the water quality portal tools, data retrieval. So this is it downloading data. And then for each of the steps, it will say dispatched. And then it will tell you what target it started. And then when it finishes, it will say completed, and then also that same target name. And then it will print out how long it took and what the size of the object was that it stored, or the file. And so you can just kind of like walk through and see, when it started one and when it ended. Obviously, the sites one takes no amount of time because it's a simple vector of sites, and it's extremely tiny again because it's a very simple vector. And then you'll start seeing these targets here. So this is that dynamic target that I was telling you about before, where it was making a plot for every site in our data set. And I would say the one unfortunate thing I don't love about dynamic targets is that they add, it has to have a name for each target that it's building. And it adds this like hash code to each branch. So when you have, 3 sites, there would be 3 branches associated with the one target. And each branch just automatically gets named whatever the name of the target was that you created, and then this random hash code. And that's just like what has to happen. That's, I would say, the one downside to this is I don't know which site this one is, and I would have to kind of dig in to figure that out. But for the power that it gives us, I'm okay accepting that undescriptive hash code. So anyway, so this is it going out and for every site creating the PNG. And then the last step here is our HTML file. And then right at the very end, it tells you at end of the pipeline and how long it took. I would go ahead and ignore all of these warning messages right now. Largely, that's on me for not recently updating things. It's just telling me I have packages that are were built in a different version of R that I don't have installed. So yeah, you may have these, and unless they're wildly old, like you had less than a 4.0 here, I would not worry about it. Okay, so that took 18 seconds to go download data and build all of these figures. So, you can click around over here in the different files. So in addition to having the phases in this, like 01 fetch.r, 02 prep.r, I also have folders that are named similarly, and that's how I organize the outputs if I have file outputs. So if you click on the 03 summarize folder, you'll see it has src and out. So src is source. That's where I put any R scripts that contain functions, just to, again, kind of keep it organized as to what is an input, which I would say code is an input to your pipeline, and what is an output, an artifact of building your pipeline. So that's what this out folder is. And so if you click here, you'll see you now have an HTML file, and you have, what is this, 6 time series files for different sites and their phosphorus data that we all just downloaded when we ran. Yeah, okay, so that's where you can find this stuff. I am going to go back to my slides because I have some specific functions I wanted to share here. Let me open those back up. Okay, so again, this is what it looks like when you build it the first time. It builds everything and is giving you a description about yeah, how it's running and how it's working. And it looked like it took 7 seconds before, and it must be because I also was not on Zoom or something when it was downloading. I don't know. Okay, if you were to immediately rerun tar_make right now, it would skip everything because there are no changes, and therefore there is no reason to rebuild any steps in your pipeline, which is a key advantage to having pipelines. It's not only reproducible, but it will skip things if it doesn't see any change or kind of reason to rebuild. There is a function called tar_viz network that's built into this package that will then visually display the targets in your pipeline. I have this additional argument passed in here that's targets underscore only equals true, because if you don't include this, it shows all of the functions too that you've written, and that was just a bit too much to put on a slide. So I kept it here showing only the target names themselves. But these are the steps that we went over, and this is how they're connected to each other. So you can see we download this P1 data set. We saved a CSV, but nothing depends on the CSV. There's no additional step beyond that. We cleaned the data by refining it, and then everything else kind of branches off of this. We created time series plots based on that. We isolated just the sites and then got their metadata. We summarized the data by site, and then we used these elements in our leaflet map. So it's a really nice way to kind of troubleshoot too. If you're developing a pipeline, you're like, oh, I thought I had connected these 2 things, but apparently I did not do that. So yeah, it's a good kind of visual check. You can also load individual elements of your pipeline. So here I'm using tar load. on this specific P2 refined data set, just to see what does that target look like? What does it create? And so this will actually load that target into your environment. So if you ran tar load, you would now have an object. Oh yeah, and Abner's sharing some of the code to do this in the chat right now. So if you ran tar load, you would then see this object pop up in your environment. And this has it's water quality portal data. So it downloaded over 1,000 observations, and it has 70 different columns associated with it. An alternative to tar load is called tar read. So if instead you ran tar read, it wouldn't load that as an object in your environment. It would simply print it to your console. So if you wanted to see what this P2 summarized data set is, you could just do tar read, and then it would just show up in your console. So it's storing this 6x7 data frame in that object. And then also kind of related to tar read here is, say you did not know where those PNG files were stored. If you run tar read on a file target, it will simply print the file name. Because this is a pattern, it also prints every branch name right before the file name. So this is one way you could link that branch hash code to whatever the file name is that it's storing. So that just gives you like, here's the location of that file. And then lastly, I did just want to share, if you wanted to open the HTML file, you can navigate to it in your folder directory, and then you'll have to click view in web browser to really, get the experience of the HTML that was created. And I can share that here in just a second. Pull R back up. So if you click on the HTML file and say view in web browser, here it is. This is what was created when you ran the file. It creates this little HTML map with dots for every site, and you can click on them, and it has the number of samples, the mean value, standard deviation, and then what percent of the samples was a non-detect value. And yeah, your pipeline just created that when you ran the code. Okay. I'm going to go back into this because I think this is the only way back in. Okay, so that's what's going on with the HTML file that was created. Oh. Hold on, I'm going to redo this because now I can't see what's coming by like presenter mode. Okay. Next, we're going to just pause again. And I want you to try, if you are doing this and following along, try changing the characteristic configuration. So that's specified in the underscore targets.r file. And it's set to phosphorus, but try changing it to chloride and then rebuilding your pipeline using tar underscore mate. So you'll have to change it and then save that file and then try rebuilding and just kind of, look and see what reran and what didn't rerun. Maybe go to where the outputs go and see what new outputs are there too. And I'll show this in just a second too. And if you do have success, please give like a chat thing or a thumbs up or something so we know. Okay, and I am just going to click over one for sake of time too. So this is what you would be changing. So in that underscore targets.r file, just update. I did give values to the right as comments. So change phosphorus to chloride here, save the file, then run tar make. If you saved the file and then you paused real quick and ran tarviz network, this is what you would see. It would show dark green targets for those that are up-to-date targets and don't need to be rebuilt. But then it would highlight in blue ones that are outdated, meaning you changed something and these are the targets that now have to get rebuilt because of the change that you made. Oh, Cassandra tried nitrate. Nice. That one has very few sites, so it's a little bit less exciting, but cool. Yeah, so when you do this and then you rebuild, these ones in blue are the only ones that will get run again, which is cool. And so then when you do rerun it, nice, yeah. When you do rerun it, you'll notice that it skips targets. So this is what the console looks like when you run. It's skipping the download. It no longer needs to download anything new. And then, yeah, you'll see here, there's actually way more PNGs being created than there were for phosphorus because the chloride, there's just more chloride sites with data in our data set. And so because it's dynamic, it's able to adjust to the number of sites. Yeah, and then it rebuilt the leaflet map too, because now it's for PNGs. Yeah, and Madison, I see your hand is up.
Yeah, thank you. So I'm curious about the like only rerunning certain things. So like step one is downloading data. So does it attempt to download and do like any sort of diff to see like if there's a difference in the data, or like is there a way to like if you know that potentially the data have changed
Yeah.
to force it?
Yeah, great question. So the way that it all comes down to how you set it up too. So the reason why it didn't re-download here is because you changed this value, so characteristic. And if you go into 0, 1 fetch, that is not part of the download step here. So it's not dependent on that characteristic. It's that characteristic value is only used in later steps. And so with how I have set this up, it would not try to re-download. If I had used that characteristic as an input to this download, it definitely would have re-downloaded the data because it would have seen a change to its own input. In terms of being able to rebuild something, even if maybe, this happens to me a lot with the water quality portal data or just really any of these kind of data downloads, is that I might be interested in this exact set in 2 weeks or something. Maybe I want the same exact date range for the same place and the same parameters. My pipeline doesn't know about the database that is hosted on Water Quality Portal. And so it wouldn't try to re-download anything because my specific inputs have not changed. But there are additional arguments. Again, I didn't get too far into this because it's a little bit more of an advanced application, but there are some commands that are called Q. And so there's a command to this where you can say Q equals, and you can actually give it like a time. Like if this has been, hasn't been rerun in 2 days, rebuild this. So you can basically force rebuilds based on like it timing out. Because then it would be able to download new data that is on the database side that's not yet on your side or reflected in your pipeline changes. Yeah, so there's a lot of like ways to kind of expand and add complexity to these pipelines for sure. But yeah, good question. Yeah, Abner.
Yeah, well, one question that was DM'd earlier that I think is relevant now is what if your pipelining, if your workflow involves some type of authentication, whether it's like from the data download or data uploading, it's like triggered every so often with this queuing function. Kind of how, yeah, is that possible, and how do you go about that?
Yeah, they're basically, I have a number of pipelines that are actually pushing data to and from SharePoint, like our internal SharePoint. And so you can set up your code to authenticate. It's just be like a step or configuration within your scripts, just like you would kind of in a basic scripting workflow. The one kind of challenge to targets is that it isn't great with interactive steps. So if your step requires human input, it's not so good at that because it's trying to run it in a separate environment. And so I've run into some issues with that, but I've always been helped by the developers when I'm struggling with something like that. And I put in a discussion in their GitHub space. But I've been able to do that by having like my own like tokens kind of saved on my computer, and the pipeline just being able to use those to log in automatically. Yeah. Yeah, I'm seeing like automated data uploads to something like OneDrive. I have code that does that for sure. That I can't share it right now, but I could share some examples of doing that for sure. Yeah, okay. The last thing I wanted to do, which I was going to do as an activity, but I think I will show, is I just want to show adding a new target, and I'm only going to show it through the slides because I already have the slides here. So you can do this too if you wanted to later and come back to this, but I actually have an additional function that's not currently being used in the pipeline that you can add later. So it exists already in a file that the pipeline is using. It's just a function that is not yet being called on. And so here in the blue square is a target that you could add right now. And actually, I'm wondering, I can, or maybe Abner, you can just like send this little snippet in the chat. And so you can add this to your pipeline. And what it does is it is a different way to summarize the data that we had cleaned. It's summarizing it by year instead of just by site. And when you add a new target, it skips things that, again, don't need to be rebuilt. It recognizes what it is dependent on, just builds that one. So you can kind of see the ones that it's skipping in the console messages here. And then you can see also in our visualization of the pipeline, there's now this additional target down here. That's nothing's dependent on it. There are no arrows kind of going to the right here. But this is just like, you add a new target and here it is. It is built and then shows up as part of your pipeline. Okay, and I can copy and paste that code to Abner because I'm realizing you actually probably don't have it. I'll paste that in when I'm done with these slides for everyone to have. Okay, I'm just going to finish up here then. So pipelines can get much more complex than this, obviously. We talked about a couple of different examples based on the questions that people had. These are just like two examples of things I have worked on. Even these seem small now compared to some of the ones that I'm working on. I would say too, when you're using that tarviz network view, what I'm showing in the slides, like this one, it's interactive, so you can actually click and drag on all the dots in your in the viewer where it pops up in our studio. Because if you don't do that, they all like overlap each other, which can be kind of frustrating. And I did not bother doing that here with these, which is why all the lines are overlapping each other. But it's completely interactive, so you can zoom in and click on different ones and see what it's connected to. So just when you get to more complicated ones, that's one key factor of the visualization of the pipelines is their interactivity. But anyways, they can get, much more complex. And I've just found them really helpful kind of frameworks now, even for just thinking about a project is like, okay, how would I organize the pipeline? Because it forces me to be really deliberate about naming and, you know, keeping things modular because I don't want a step that takes forever to rebuild. I want to keep them kind of light and small. And so the last two slides that I have to share are just things that I think you could read later that are just like additional information to consider with pipelines. Just some things about, you know, when you're architecting them, what to consider, how to debug. And then, yeah, when you're going to scale them, you can run targets in parallel. You can also have targets that are, you know, maybe you have a couple of steps that are actually Python code. There's a way to integrate that. So yeah, they can really get much more complex. And then the last thing that I wanted to leave you with, and I was hoping for more time for discussion, but in true fashion, workshops take much longer than you think they are going to. But here are some links. I do have them in the notes too. So if you scroll down under the resources for this session, you'll see additional links that are shared in the slides. So all of these are there. A bunch of targets ones, the documentation, various tutorials and things that we have found. But then also just two tools that I'm familiar with for pipelining that are outside of R. So one is SnakeMake. I have not used this at all. Abner has dabbled in it. And I think I've met some USGS colleagues that are way more advanced in SnakeMake usage. So I could probably point you to some people if that's something that you're interested in. I know there are some limitations. I think targets is a bit more user-friendly right off the bat, but SnakeMake is a pipelining tool that is out there and available to use. And then the last one is a language agnostic tool that I actually used to use prior to targets coming out, but it's all based on YAML files, kind of orchestrating the steps in your pipeline and their connections. So while it is language agnostic, which is great, I would say it's not as kind of beginner welcoming if pipelining is new to you. But I wanted to share them regardless. So those are all linked later, or not later, in the notes doc. And yeah, we have 4 minutes, which is way less time than I thought we would have. But if you could add these, you know, maybe the chat, maybe raise your hand. And if not here, if you could just, you know, add these thoughts that you might have based on these prompts or anything to the kind of closing section in the notes, which is also up there, I'd be really grateful for it. You know, I keep going around telling people about targets and trying to get people to adopt it or just adopt kind of the modular approach that it forces you to take. And following some of those conventions, even if you're still just using scripts and not fully pipelining. But yeah, I guess I'd be curious to hear, yeah, you know, what potential you see for this, maybe what are some kind of initial limitations or challenges you would anticipate for others trying to use something like this. And yeah, just kind of like general reactions to the tool. So feel free to add those, you know, later after the session or yeah, in the chat too. And if anyone feels like compelled to speak, please do so. Everyone's typing feverishly, so that's great. Oh yeah, Madison. Oh, Julian is also. Julian, go ahead first, and then I'll call on Madison. Yeah.
I just had a question going back to the collaboration aspect that you mentioned at the beginning. And could you just tell us a little bit more about your setup in terms of collaboration? Is it pushing the code via GitHub or something else?
Yeah, it is. I push everything to GitHub. And so we're able to work on the pipeline together through GitHub. I would say one thing that helps with collaboration is being really intentional about you know, in GitHub, I don't want to push any of my data files up, but I may have what I call log files. So I'm creating like a summarized version of the data that shows the number of rows, the number of, I don't know, maybe mean values or something like that, so that we can version control that. And so if I build something and make a pull request, somebody could quickly see like, oh, you added new data and here is kind of how it's changed the pipeline. So that's a tool Abner and I use. And also Git committing plots is a pretty big thing with when I'm building pipelines collaboratively, so that we can all kind of keep track through our pull requests, like what's being updated and changed as things go. I have not found a perfect solution yet for like sharing intermediate data products in like a single location and having us all have pipelines that build based on that. That's maybe the one limitation I've run across, is that I'm gonna have to rebuild the pipeline on my computer. Yeah, there are definitely ways to do it. I haven't really bumped up against a need yet to really dig into it. Targets could definitely do that. It's just not available quite right away. Yeah. Yeah, Madison.
Yeah, I just want to say thank you so much. Like, this is really the first time I've like had a deep dive into pipelines, and it's been really great and eye-opening. And I put this in the doc, but I was just trying to like synthesize like all the benefits of going this pipeline route, as opposed to just like normal scripts that you would run. And I came up with 3, and I wanted to know if I was like missing anything or kind of on track. So one thing is like it would spin up in a separate environment for somebody, so you wouldn't have to like share a separate kind of environment file for them to get going and rerunning. Is that true?
Yeah, so environment, when I was saying that, is probably like an R person's definition of an environment, which is just that like when you're in our studio, when you have it loaded, you have this kind of like current global environment. And if I were to load an object or a library here and then try to run the pipeline, my pipeline wouldn't know about that. It's not an environment in terms of like, you know, like a Python like environment config file where it's literally spinning up and like installing packages and stuff for you.
Okay.
So it's a
Got
little
it.
bit different in that way. Yeah.
Okay.
But the
That's
other two
helpful.
things I definitely agree with.
Okay. Awesome. Thank you so much.
Yeah. Yeah, the like not rerunning steps when nothing has changed, I think is key when you have certain parts of your workflow that take longer than others. And a default for me when things get really complicated and I don't have a pipeline is to just rerun everything, because I'm nervous that I might be missing, you know, one step that needed to be updated, and that ends up with, you know, me like rerunning steps that might take hours. And the pipelines kind of help sort out, yeah, those connections. You do have to invest the time in building it that way, but once you have it that way, and yeah, it's really handy. So definitely an investment up front, but big payoffs I find later. Okay. So yeah, thanks everybody. I'm sorry the discussion could not be longer. I wish it was. But yeah, I really appreciate the questions and just interaction here. I am such a pipeline nerd that if you email me or reach out to me in any way, I will talk about pipelines forever. So yeah, please do reach out if you have any additional thoughts on this. Yeah, and thanks for joining. Oh yeah, Cassandra. I will email you about the OneDrive stuff. Yeah.
Thank you.
Because
This is
yeah,
such a great workshop too.
oh yeah, thanks. Yeah, the examples I have are like ones I've built for our like internal payroll stuff, so I can't just like pull them up right now, but I can share an example version later for sure.
Yeah, definitely. Just an example is fine.
Yeah.
Really cool to see everyone so excited about using pipelines. That's kind of how I felt over the past several months working with Lindsay. So yeah, really cool if others feel the same.
Making everybody slowly a Python, or not Python, a pipeline enthusiast. That's my like goal in life.
It's a great goal to have. All right, well, thank you very much, everybody. We'll have the recording up on the eSIP channel in a couple weeks.